Let's review. So like I said, we're going to be reviewing everything, all of the topics that are on the test. So that includes exponents and radicals, rational and irrational numbers, and all of this, which is exponential functions. So we're going to start off with exponents and radicals. So right off the bat, here we go. Which of the following is a true statement? So in all of these examples, we have an equal sign. We have an equal sign. But we have to figure out which of these is actually equal. Which one actually matches left side and right side. So there's kind of a lot going on, right? I see, what do we see? What types of things do we see in this problem that we're going to have to deal with?
Exponents and radicals.
We have exponents, we have radicals, and what types of exponents specifically? Just regular exponents?
Fractions.
Yeah, we got fractional exponents. So when we have fractional exponents, let's quickly review how this works. Okay, if I have a to the power, actually no, let me make that m to the power of a over b, how can I rewrite that?
Radical
Mhm.
b on the outside on the balcony, m by the power of a.
Good, exactly. So this is the rule. This is the rule for fractional exponents, and that's just something that we're gonna have memorized. Okay, so if you don't have this memorized, I want you to write it down right now in your notebook. The more you write things, the easier they are to remember, because your brain is connected to your hand. It's kind of like how, once you learn how to ride a bike, you don't really forget because your brain has memorized it. It's muscle memory. Okay, so the more you write things down, the more you're going to memorize them. Okay, so that's the rule. That's the rule we're going to follow. And so basically what's going to happen is we have to check to see if these two sides match up. So for example, let's start with example A. I'm just going to rewrite example A over here. So in example A, I have a radical, but that radical has a number out on the balcony. Now, when that happens, usually that's a whole number, right? Usually the number that's on the balcony is going to be a whole number. Now, in this case, it's a fraction, so we kind of have to be a little careful with it. But basically, I know I'm going to turn this into an exponent. What goes in the numerator?
In the numerator, 1.
Good. And that's because on the inside, there's an invisible 1. So I got a 1 in the numerator, and what do I get in the denominator?
2. Wait, no.
What's on the balcony?
1.5.
1/2. 1/2 is out on the balcony. That whole thing is going to go in the denominator. So I have 1 over 1/2 equals x. And we're not sure if it equals x yet. We're trying to see. Okay, this is a little weird because I have a fraction within a fraction. But remember, what operation is a fraction actually doing?
Dividing.
Dividing, exactly. So when I have 1 over 1/2, that's the same as 1 divided by 1/2. So I'm going to actually, let me rewrite that. I'm going to do this in blue because I'm just going to do this on the side. 1 over 1/2 is the same as 1 divided by 1/2. But now, okay, now I'm doing 1 divided by a fraction. When you divide fractions, what's that fun little acronym that we remember in order to do that?
KFC.
Yeah, KFC. Except it's not KFC, it's KCF.
Oh, keep change flip.
Keep change flip, yeah. We're going to keep change flip. So we're going to keep the 1. Change. What does C stand? What do I do with change?
We have to change The fraction, we have to turn it around,
Mm-hmm.
and we're gonna also change the symbol to a multiplication.
Good. So keep means I'm keeping this first one the same. Change means I'm going to change it from division to multiplication. And flip just means I'm going to flip the fraction. So this is the same as 1 times. What's 1/2 flipped? Oops.
2/1.
2/1. And what's 1 times 2?
1
Times
No.
2.
2.
2. So in the end, here's what I get. I get x to the power of 2 equals x. Now, is that true or false?
False.
That is false. They do not match. So what we're doing with each of those answer choices is we're trying to see which one is true, right? So we got to check to see if they match on both sides of the equation. And in this case, we had to do KCF. So does anyone have any questions on this? When I had to divide, I had to do 1 divided by 1/2.
Why didn't you add the 2 on the outside of the parentheses?
Because I totally forgot about it, Ajara. Oops. Let me do that then. My bad, guys. Actually, no, I'm not going to delete that. I'm just going to make it a little bit smaller. Okay. So, okay, my bad. There was a 2 there that I forgot. Let me put it back. So pretend it was there all along and Miss Lopez didn't forget about it. Okay, there it is. Now what do I get in the end?
Since we're going to distribute, 2 times 2 equals 4.
2 times 2 equals 4. So this is even worse. This is actually x to the power of 4 is equal to x. And again, that is still false because when x is all alone, what's the invisible exponent on it?
1.
Right. And that simply can't be true. They do not match. They do not match. So thank you. Any questions on this one? Look through it, go through each step, check to make sure that you understand what I did. This situation here where I had to divide also is, make sure you understand that part. Okay, any questions? Going once? Going twice? Okay, it's not A. So now I gotta check B. And again, we're just checking to see if the left side matches the right side. So here's B. We have the square root of x to the power of 1/2 equals x. Maybe it equals x, we'll see. Okay, so here I have the square root of x. What's the invisible number on the outside?
2.
Good, a 2. What's the invisible number on the inside?
1.
1. So using my rule, which number goes into the numerator?
1.
Good. 1 on top, 2 underneath. Bring down my extra exponent. Okay. Questions on that first step? Cool. Well, now what do I have to do here? What operation am I doing between those two exponents? One's on the inside of the parentheses, one's on the outside of the parentheses. Should I add them? Should I divide? What should I do?
Multiply.
Multiply, good. remember, anytime you have exponents and you got to distribute, that's multiplication. So we multiply those exponents. So what's 1/2? 1/2 times 1/2.
1/2. No. 1/4.
1/4, good. How do we multiply fractions again?
Straight across.
Straight across. So I have x to the power of 1/4. Does that equal the same thing as just x?
No.
Nope, no match. No match for B. Check this one out. Take another 30 seconds to look through what we did, right? Make sure you're writing everything down. Write it all down, because like I said, the more you write, the more you remember. So look through it and let me know if you have any questions on this one. Okay, questions going once. Going twice. Okay, time for C. Let's see what happens here. Now there's a lot more going on this side, right? We got something on the left. We also have stuff going on the right side. So we're gonna have to work with both sides this time. Okay, lots going on. Now on the left side, that should look pretty similar. Doesn't that look similar? Familiar? Have we done that already?
Yes.
For
letter B.
For B, right? Did that already over here. What about the right side?
It's changed.
Does it look the same as something we already did?
Oh, B and A.
A, yeah. So we kind of already did this. So that's kind of nice, but let's just go through it again. So here, the square root of x, we have an invisible 2 on the outside, an invisible 1 on the inside. So again, I get x to the power of 1/2 to the power of 1/2. Now on the right side, this was x to the power of 1 over 1/2. And we did this before. 1 over 1 divided by 1/2 is the same thing as 1 times 2. So that's 2. So on the left side, we multiply these two together. And I get x to the power of 1/4. And on the right side, I have x squared squared. So when I multiply those, I get x to the power of 4. So does x to the power of 1/4 equal x to the power of 4?
No.
Nope, they don't match. Those are not the same number. They're similar, but 1/4 is a fraction and 4 is a whole number, so they do not match. Questions on this one? Okay, so it looks like it's going to be D, doesn't it? But I want you guys to take about a minute and try working it out in your notebook. I'm going to leave my example C up here so that you can kind of look at it and see if there's something similar. Maybe it'll help you out. But try D on your own first. So try and see how you can get both sides of that equation to match with each other. And then we'll go through it together in about 1 minute. All right, take about 15 more seconds. All righty. Here we go, here we go. Answer choice D. Let's take a look at it. So the square root of x to the power of 2, and then x to the power of 1/2 to the power of 2. So on the left side, what do I have to do first?
Turn the radical into an exponent.
Good. Turn this radical into an exponent. And we did a very similar one before. There's a 2 on the outside and a 1 on the inside. So what's my exponent going to be?
X 1/2.
Good. X to the power of 1/2 squared. And oh, look at that. I have x to the power of 1/2 squared. So already I have the same thing on both sides, but let's just finish it. What do I do here on both of these? What operation?
Multiply it.
Good. We distribute, so we multiply. And what is 1/2 times 2?
1/2.
Times 2. Oh, wait, what did you say? What did you
I
say?
said 1.
1. Oh, I heard you said 1 whole and I heard 1/2. Yes, it's 1. It is 1. So we end up with x to the power of 1 on both sides, making D my answer. So this one is very similar to what's going to be on your test. You might see a question pretty similar to this one, where basically they're just asking you which of these matches on both sides. So you're going to have to use those rules to kind of flip back and forth between a radical and an exponent in order to see if there's a way to get them to match with each other. Any questions on this problem? Cool. Let's do a very similar one. We're going to do about 3 of these. I apologize. This one came out super, super blurry, so I'm actually going to rewrite all of these so you can see it a little bit better. But this one's very similar. Very, very similar. You're going to see if both sides, each of these matches. So what I want you guys to do is just start going down. Go from A and start going down. And see if we can figure it out on your own before we do it together. Take about 2 minutes and work your way down. And then we'll go through it together. And if you have questions or you want to ask maybe if you got the right answer or not, just let me know in the chat. Okay, about 45 seconds remaining. All right, about 10 seconds remaining. If you want to check your answer, you can send it to me in the chat and I will let you know if you got it. All righty. Okay, so all of these have the same thing on the left side, right? Same exact thing. So I'm just going to check that, and then just by checking it, we'll get the answer because it's only going to match one of these. Right? So here's my little expression, x to the power of 1 over k times k. Remember, we multiply this. But I don't have numbers, I have variables. So we got to kind of multiply these. Even though they're not actual numbers, we're still going to follow the same rules. If I'm doing 1 over k times k, how can I rewrite that?
1 over k times k over 1.
Good, times k over 1. And that just helps us to see it a little bit better because now I have two fractions. And when you have two fractions, you multiply them how?
Straight across.
Straight across. So 1 times k is k, and k times 1 is k. Well, what happens here? What happens when you have the same number on the top and the bottom?
It's just that number
Equals to 1.
It equals 1. It equals 1. That was the kind of the trick you had to figure out. Because let's think about it like with any other number. Let's say you had 1 over 3 times 3 over 1. 1 times 3 is 3. 3 times 1 is 3. And 3 over 3 is 1. So if you think about it with any other number, you're going to notice that the answer is 1. So my exponent is 1. So if I have x to the power of 1, that simplifies to just x. So that's answer choice D. Questions on this one? Questions? Ask them now. Now's your chance.
I turned them all into radicals.
You turned it into a radical instead?
Yeah.
Okay, well, that's actually really important to bring up. When things are radical form instead of exponent form, they're a little bit harder to work with. So it's more useful if you keep things as an exponent for as long as you can. And then maybe in the last step, you can change it into a radical. But if you keep things as an exponent, you can follow all of those exponent rules. So it's more valuable, it's more useful to keep things as exponents. Take a moment, make sure you write it all down, make sure you understand it. If you have any questions, now's your chance. We're going to do, I think, one more that is similar. All right. Final chance for questions, going once, going twice. Okay. Someone asked, what is k? K is just a number. K is just a variable. We don't know what it is. But the whole point of it, it doesn't really matter what it is, right? Because what happens in the end is it cancels itself out anyways. So no matter what number k is, no matter what, even if it was 1 million, it would still cancel out and leave us with 1. All right. Here we go. Kind of similar. Now, actually, I want to do this one together because it's a little bit trickier. So which expression is equivalent to 7 to the power of k to the power of 2, where k is an even number? Okay. So again, this whole k situation, right? But remember, it doesn't matter what k is. We're just trying to see if one of these answer choices is going to match with 7 to the power of k to the power of 2. So let's start with the first one, A. 7 to the power of 2k, we're trying to see if that's equal to 7 to the power of k squared. Now let me ask you this. Since I have the same base number on both sides, I have 7 on both sides, if these two sides are equal to each other, that would mean that 2k would have to equal k squared. Now, does it? Does 2k equal k squared?
No.
It's not the same thing. Remember that. It's not the same thing. Let's say that k, let's just pretend for a second. Let's say k is 6. Is 2 times 6 the same as 6 to the power of 2?
No.
No, because what's 2 times 6?
2 times 6 is 12.
And 6 to the power of 2 is
36.
36, right? So those do not mean the same thing. So for that reason, I'll keep this here. For that reason, the first answer choice is incorrect, because the two sides of that equation simply do not mean the same thing. Questions on A? Okay. So it's not A. What about B? 28k to the power k. How do you get how is 28 related to the number 7? Are they related at all? Does 7 and 28, is there any relationship?
No.
Not at all?
They're both, or you can multiply 7 by like 4 to get 28.
Yeah, they're both in the same multiplication family.
Good. So 7 times 4 is 28. Okay. Well, let's just replace the 28 with 7 times 4, since they're equal. Okay, what do I do with this exponent? I see parentheses. What should I do?
Distribute.
Yeah, we could distribute it. And let's just see what happens. 7 to the power of k times 4 to the power of k. Does that give me the same thing as my right side?
Yes. Wait, no.
Do they
No.
match?
We can't combine like terms since they're not the same base number.
Yeah, we can't combine like terms. We can't really do anything at this point. So left side and right side, simply they just don't match. This doesn't give us what we want. So it's not B either. Oops. Okay, it's not A, it's not B. Okay, we keep going. Let's check C. Okay, is there a relationship between 49 and 7?
Yes, they're in the same multiplication family.
Yeah, how do I get to 49 from 7?
7 times 7?
7 times 7 is 49. What's another way to write that?
7 to the power of 7? Of 2?
Good. 7 to the power of 2 is 49. Okay. So I'm going to rewrite 49 as 7 to the power of 2. So I have 7 to the power of 2 times k. Ooh, this is looking pretty close. What's the last thing I got to do here?
Multiply K.
Review.
The K2 would be backwards, so
Good. So this, we
it would
multiply
be
it.
7 to the power of 2k.
And we already kind of saw that, didn't we? That's similar to, that's the same as what we had in answer choice A. So they almost match, but they don't. They're not the same. So it's not A, it's not B, it's not C. So now let's look at D and let's see why D is the one we want. Okay, 49 to the power of k squared over 2. Okay, we already said that 49, or that 7 squared gives me 49. So I'm going to rewrite the 49 as 7 to the power of 2. Now I have this big old exponent here. But we know that we're going to have to distribute and multiply. So I'm doing 2. Let me do it in green over here. 2 times k squared over 2. How do we multiply these? I have a fraction and a whole number. How should I multiply them?
Turn the whole number into a fraction.
Good, that's a really good way to do it. So 2 is the same as 2 over 1. And then I go straight across. So I have 2 times k squared. So it's 2 times k squared over 2. Does anything cancel out?
The 2.
Yeah, those two cancel out because I have a 2 on the top and a 2 on the bottom. They cancel out. So what am I left with?
K to the power of 2.
Good. I'm just left with k to the power of 2. So my final answer on the left side is 7 to the power of k to the power of 2. And guess what? They match. So it's D. Seems like all of these answer choices, they want us to really try everything until we get to the last option, right? Because everything is always answer choice D. They're like, oh, you're going to spend time on this problem. Questions on this one? So remember the strategy, okay? When you get to a problem like this, because there will be problems like these, you have to just play around with it, figure out a way for the left side of the equation to match the right side of the equation. And you got to keep working to see if there's any way to make it happen. And just make sure you're always following those rules. Any questions, any final questions on this topic? Because I think that's it. Okay, I have one more. Any final questions? Going once? Going twice? All right. Last one for exponents, I promise. Same idea though, which now in this case, we actually have numbers, which for a lot of you guys, this is nice. This is a little bit easier. There's no variables, it's all actual numbers. You're trying to see which of these are true. So again, I'm going to give you guys about 2 minutes to start working on it on your own. See how many you can do on your own. 2 minutes, and then you can check your answers in the chat, and I'll let you know if you're right or wrong. Okay, about 30 more seconds.
30 seconds.
30 seconds. It's okay, do as many as you can in that time. If you don't get to all of them, that's fine. All right, 3, 2, and 1. Here we go. A. Now, there's more than one way to do this, by the way. There's a few different ways to do each of them. So try different things, but remember, you can always follow those rules. You can turn radicals into exponents, or you can turn the exponents into radicals, and both ways will work. So in example A, who can give me what should I do?
Put a 2 and a 1.
The 2, say that again?
Put a 2 and a 1.
A 2 and a 1. Okay, so, oh, on the outside, I got you now. I got you. So this is a 2, and this is a 1. All right, so that would be 64 to the power of
1/2.
1/2. Good. We're trying to see if this is equal. Okay. Now, can I simplify anything?
Yes.
Yeah, what can I simplify?
The 64.
Okay, how
Wait.
would I simplify?
The 6 and 2 and 64.
The 6 and the 2.
Yeah, the 6 and the 2. That's what I was thinking. Because you can simplify that fraction. What is 6 divided by 2?
3.
3.
3. So I have 64 to the power of 1/2 equals 3. Sorry, equals 2 to the power of 3. Okay. From here, what else could I do? Remember, you can always flip back into a radical or keep things as a fraction.
Flip it back into a radical.
Yeah, I think that would be a good idea because remember we started with this, the square root of 64. Can you actually do the square root of 64?
Yes.
What is the square root of 64?
8.
8. So sometimes it's actually easier to keep things as a radical because if you can actually do the radical, if you can do the square root of 64, that's going to save you a little bit of time because now I can just get a whole number. This is 8. And then what's 2 to the power of 3?
8.
Also 8. 2 times 2 times 2 is 8. So we got a match. They do match. And so you see how you can kind of play around with it. There's a lot of different ways to do this. And some of you might have gotten the same answer, but doing it a completely different way. So does anyone have questions on A? Okay, awesome. All right, let's look at B. Similar thing with B. We're gonna play around with it, see if we can kind of make them match. All right. Any suggestions?
Turn the 4 by 3 and 2 halves into a radical.
Okay, sounds good. What goes on the outside?
2.
What goes on the inside?
3.
Cool. Now that I have a radical, you have to ask yourself, can I do the radical?
Yes.
Yeah, I sure can. What is the square root of 4?
2.
It's 2. So this is 2 to the power of 3 equals 2 to the power of 3. We have a match.
Oh, I didn't do that.
How did you do it?
I just solved it. I did 4 by the power of 3, gave me 64. And we all know that 64 to the power of 2 equals 8. then 2 by the power of 3 equals 8.
Good. That's a completely valid way to do it as well, because you could have done, hold on, let me write this. The way you did it also works, Ijira. And that's the beauty of these problems, is that you can kind of choose your journey. So she did it this way. She did, okay, 4 to the power of 3. That's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. And then the square root of 64 is 8. And then 2 to the power of 3 is also 8. It worked out, right? You got the same answer. Different way to do it, but you get the same answer. So as long as you're following the rules of exponents and the rules for radicals, you're going to get the same answer, because if the rules are rules, they're always going to lead you in the right direction. Questions on this one? Yeah, B and A were pretty much the same. They gave us the same numbers in the end. Okay, C. C looks challenging, doesn't it? There's a lot going on in this one. But again, we can kind of work with it. So first of all, with C, what I would say is try to do as least amount of work as possible. Because with C, a lot of you might be tempted to actually try and figure out what is 16 or 36 to the power of 2. You might want to do, okay, 36 times 36 and figure out what that is. But that is kind of a lot of work, because if you don't have a calculator, which you won't on this question, now you got to do this multiplication problem. Whew, that's going to be a lot of work. So my suggestion is try to do the least amount of work as possible. Where can I begin? What can I do first?
Changing the radical into an exponent.
Radical into exponent. Okay, 216 to the power of
1/3.
Okay.
not 1/3. What goes in the numerator?
What?
So careful, the 4 that's on the outside. Okay, let me actually rewrite this. The 4 that's on the outside is the same thing as if it was on the inside. It's the same thing. Okay, so just
So 4/3.
so it's 4/3. Good.
Oh, I thought we had to distribute.
But you get the same answer, don't you? Okay. So now, this is way more challenging, right? Because these numbers are not very easy to work with. Does anyone have any suggestions? Okay, I see somebody's telling me, okay, try to do 36 to the power of 2. So 36 times 36. That's going to be kind of a lot of work, but you know what? Let's go with it. Let's just see what happens. Because I don't have a calculator for this problem. So 6 times 6 is 36, carry the 3. 6 times 3 is 18, plus 3, that would be 19, 20, 21. Then 3 times 6 is 18 again. Carry the 1, 3 times 3 is 9, plus 1 is 10. Here we go. 1296. It's kind of a big number, right? Not much, but it still doesn't really match. But, does anyone notice anything that's matching here? Yeah. See how I got 216 here? That's what I got when I did 36 just times 6. 36 times 6 gives me 216. You can try it out. I'll do it real quick. 6 times 6 is 36. 6 times 3 is 18, 19, 20, 21, 216. So 36 times 6 is 216. Well, that means that 6 times 6 times 6 is 216. How do I rewrite that?
6 by the power of 3.
6 to the power of 3 is 216. So I'm going to rewrite this. 6 to the power of 3. I'm going to rewrite it over here. And how do I rewrite 36?
6 to the power of 2.
Good. Now we're going to see if they match. So I got to multiply on the exponents. What's 4 over 3 times 3?
3, 12. 12 over
12 over 3. And what's 12 divided by 3?
4.
4.
So I got 6 to the power of 4. And then over here, 2 times 2?
4.
4. We got a match. See, this one was much, much more challenging. There was definitely a lot more to work out in this problem. Questions on this one? Okay, almost done. Oh my goodness, we are so low on time. That's okay, this is important. I would just want to make sure we understand this. Okay, but the last two are a little bit easier. 8 to the power of 1/2, and then 16, the square root of 16. So I can rewrite the square root of 16. There's a 2 on the outside and a 1 on the inside. So this is 8 to the power of 1/2 equals 16 to the power of 1/2. Now, is that true or false?
Oh, wait, if you divide 16 by 2, it's 8.
Okay, so 16 divided by 2 is 8. So this would be, or 8 times 2 is 16. 8 times 2. But that would be 8 to the power of 1/2 equals 8 to the power of 1/2 times 2 to the power of 1/2. Does that match?
No, you could do 2 by the power of 4.
Ooh, okay. I'll do that. That sounds good. Okay, so this was 16, right? 2 to the power of 4 is 16. 2 to the power of 3 is 8. So I can rewrite this. Oops. And then do a little bit of multiplication. 3 times 1/2. 3 times 1/2.
1
3.
1/2.
1.5, or how else can I write that?
3 over 2.
3 over 2. And then 4 times 1/2
2.
is 2. Do they match?
So
Nope.
Kind of.
Kind of, but no, you need 100% match. And they don't. So D is out. And then finally, F, or E, I mean. Square root of 36 is?
square root of 36 is 36 by the power of 1.5.
1/2. Okay, so this is 36 to the power of 1/2 to the power of 1/2. What's 1/2 times 1/2? Straight across.
1/4.
1/4. Does 36 to the power of 1/4 equal 18 to the power of 1/4? Do we have a match?
Wait, what was the question?
Just do these sides, do they match?
So
Nope. E is out. Okay, I know that I kind of sped through those last few problems, but I do want to move on because we've only done one of the 3 topics that's on this test. So do I have any final questions about kind of how to do these problems? Okay. All right. So that was exponents and radicals. Now I'm going to quickly do just 2 quick problems about rational and irrational numbers. So here's the first one. Actually, no, I want to do this one. This one's a little bit better. So they're showing us what each of those variables is. And so I want to go through and I want you guys to tell me if this is a rational number or if it's an irrational number. So for L, the square root of 2, is that rational or irrational?
Irrational.
Good. How about 3 times the square root of 3?
Rational.
What is the square root of 3?
Decimals? Oh, wait.
Plug it in your calculator. Check really quickly. What is the square root of 3?
It's irrational.
It's
1.732050 blah blah blah.
long decimal. So that's irrational. How about the square root of 16?
Rational.
Good. What is the square root of 16?
2? Wait, no. 3. No, wait. 6.
No.
No.
The square root of 16?
4?
4, which is a rational number. How about the square root of 9?
Irrational.
What is the square root of 9?
Oh, 3.
Is 3. What type of number is 3?
Rational.
Rational. Okay, so here's my numbers. Now we're going to see which one ends up being rational. So L plus M, rational, irrational plus irrational. What does that always give me?
Sometimes rational.
Sometimes it's rational. M plus N, that's irrational plus rational. What does that give me?
Never rational.
Never rational. How about this one? N plus P. So rational plus rational.
It's rational.
Always rational. Good. That looks good so far, but let's just double check the last one. P plus L, that's rational, plus irrational, which again is what does that end up with? When you mix and match, you end up
Never rational.
never. Good. So the one that will always give me a rational answer is C. Now, A is sometimes rational. So if I just double check, because you always want to double check, the square root of 2 plus the square root of, or 3 times the square root of 3, the only time where you would get a rational answer is if they cancel each other out. So do these cancel each other out?
No.
Nope. So this is irrational. So let me explain that one more time. Let's just say, for example, if you had the square root of 3 plus the negative square root of 3, if you have the square root of 3 and then you take it away, what do you get? If I give you a square root of 3, happy birthday, and then I take it away, what are you left with?
0.
0. So the only time that you do get rational from two irrational numbers is if they cancel out to 0. So that's why you have to check just to make sure. You got to check. But in this case, they did not cancel out, so the only answer is C. Questions on this one? How do you know if it's an irrational number or a rational number? Go back and watch my video because I don't have time to explain it right now. That's something you got to check. Okay? Because I've been over it like 3 times now. I don't have the time to do it again. Okay. Now we're going to quickly go through these as fast as we can. Linear versus exponential. So we're going into exponential functions now. Take a look, and using the annotation button, go ahead and put a check mark where you think a check mark belongs. Remember, you can use the stamp button, and in the stamp buttons, there's these little check marks. If you don't have that button available to you, you can just draw a check mark where you think it may belong. Go ahead. Here, I'm making it anonymous now, so you can't see the names come up. So more of you should be able to do it now. If you were feeling shy before, because you didn't want your name to pop up, no more names. Just go ahead and put your answers where you think they belong. All right, cool. So I'm seeing some good answers. However, it looks like there's a little bit of confusion. I don't see a whole lot of answers here. I only see one person so far. So maybe we have questions about that one. But everything else seems pretty straightforward. I will say one of these is incorrect. One of these is completely incorrect. So go ahead and take a look, see if you can figure out which of these you're going to want to switch. If you're not sure, okay, let me give it away. So I'll go from bottom up. Okay, bottom one. The school bus is traveling at 45 miles per hour. Yeah, that's definitely linear. That's good. Speed. Speed is the same as slope, which is linear. Next one up. $1,000 investment accumulates compound interest. Compound interest is exponential. So that one is correct. Next one. Every 24 hours, the number of viral cells in the sample doubles. There's our multiplication word. Multiplication words are also exponential. That's good. Next. Temperature increases by 4 degrees every hour. No, there's no multiplication words, there's no exponents, there's no percentages, so this is linear. Okay, value of a house increases by 1.5%. Percentages are exponential, so that one's good. And now here, okay, so somebody switched sides. Somebody switched sides. Good job to that person. This looks for a second like it might be exponential, but there's a key word that actually makes it linear. What is that word?
Accumulates.
Nope.
Simple.
Simple. Simple interest is linear. Compound interest is exponential. So I'm going to write that down over here. Simple interest is linear. Compound interest, we kind of went over this on Friday. Compound interest is exponential. So for that one, those were incorrect. Don't be fooled by simple interest. So any questions on that one? Everything else was perfect, but I just want to make sure we get that difference, that simple versus compound. Questions going once? Going twice? Cool, next up. Okay, we kind of did this in the bell ringer, so I'm not going to spend too much time, but how do you figure out if something is exponential?
You divide from the bottom to the top.
You divide from the bottom up, exactly. Divide, you divide, 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 and you check to see whether you get the same number each time or a different number each time. And so, okay, super quickly, 19,144 divided by 18,223, 1.0499. Next to 18,223 divided by 17,364, 1.0500. 17,364 divided by 16,538, 1.0499. So already you can pretty much tell that this one has a constant factor. Of 1.05. Now, if I do the same thing on the other hand, 16,561 divided by 16,236, 1.0200. 16,236 divided by 15,918, 1.0199. So far looks pretty good. 15,918 divided by 15,606, 1.0199. 15,606 divided by 15,300, 1.02. What do you think? Constant factor, yes or no?
No.
No? Why not?
Well, they're somewhat close, but
Do they all round to the same number?
yes. Is that you put the 000 to it?
Yeah, that was a typo by accident. So yeah, we
Constant.
got a constant factor. 1.02. Which one is growing more quickly?
Painting a
Painting A is growing more quickly, and it's growing by a constant percent rate. Just keep that in mind. Look for that keyword percent because it's exponential. Questions on this one? Okay, I kind of sped through that one, but remember, on a test, you have time, go all the way to the top. Check each and every one. All right, next one. Okay, the value of a certain stock has increased 5% per day for the past 10 days. The initial price of the stock was $30 per share. Write a function that represents this situation. Okay, for this one, remember guys, just gonna go through this really quick. Let's see, what does A represent?
starting amount.
Starting amount. How about R?
Growth rate.
And how am I supposed to write it?
In the decimal form.
Decimal form, good. Okay. So I see Juan already gave that to us. 5% is 0.05. So when I write this, I'm going to write f of t equals 30, starting amount, times 1 plus 0.05 to the power of t. But what do I have to do now to get my final answer? Is that it? Should I write it just like that in the box?
So
What should I
we
do?
have to add what's inside the parentheses.
Good. We're going to add those two together.
Meant simplify, I'm sorry.
Nope, add. You're right. We're going to add. Now, we're not going to plug in the 10, Juan, because this is telling us, it's not telling us to do so. It's just telling us to write the function. We're not going to evaluate the function. If it said, okay, now find the price of the value of the stock after 25 days, then you would plug in 25. But it's not asking us to do that. It's just telling us to write the function. So the final answer will be 30 times 1.05 to the power of t. Questions on this one? So this goes back to somebody in the bell ringer asked me, how do you know when to add and how do you know when to subtract? In this case, how did I know that I had to add? Where's my keyword? Look back at the problem. How do you know that this is growing?
Increased.
Increased.
Increased, exactly. So then in this case, I knew that I had to add. Now in this case, where's my keyword?
Decreased.
Decreased. But it's the same process, okay? So this time I'm going to be subtracting 1 minus r to the power of t. But it's the same exact thing, because what is my percentage as a decimal?
0.15.
0.15.
Good. My starting amount is 100. So I get f of t equals 100 times 1 minus 0.15 to the power of t. And when I subtract, what do I get? Good one, 0.85 to the power of t. And this is where I want to make sure we completely understand. 0.85 is my decay rate. But what is my percent decay rate?
15.
15%. So if you are looking in the parentheses, you're not going to see the percentage. You're going to see what was left after you took away that percentage. So you want to make sure you're very careful. If they ask you for the percentage, you have to subtract. You have to do 1 minus the number you see. 1 minus 0.85 brings me back to 0.15, and that's how you get 15%. Questions on this one? Okay, 10 minutes left. I'm gonna keep rushing through this. Okay. The starting annual salary for an office worker is $29,000. If the company awards an annual increase of 6.2%, which graph models the situation? Okay, so we're looking at graphs. We haven't done too much of this, so I just want to kind of go through that again. 29,000 is the starting amount. So which answer choices are out?
C and D.
How do you know?
Because they both start at 5,000.
Good. Look at the y-intercept, okay? These don't start at the right place. And then my annual increase is 6.2%. So this is where we got to be a little careful. So if I write this as a function, just like we did in the previous problems, 6.2%, what is that as a decimal?
0.0062.
Yeah, good. Okay, so my function is going to be 29,000 times times 1 plus 0.062. So that's 1.062 to the power of t. So the way to figure out, in order to figure out which of these it's going to be, if it's going to be A versus B. So let me zoom in and let's just look at what happens in A. So if I make a little table for A, I know that it starts at 29,000. Approximately what happens at 1 after 1 year. It's okay if it's approximate, but approximately where is it after 1 year? Just give me
For A or B?
for A.
A.
Yeah.
It's in the middle of 31,000
So
somewhere.
yeah, I would say it's about somewhere about 31,000. Okay, in B, we know it starts at 29,000. Where is it after 1 year?
After 1 year, 45,000.
About 45,000, right? It's like maybe a little bit more, but that's a good estimate, 45,000. Okay, so that's what the graphs tell us. Now we're going to match it to the correct graph, because if this is the function, we know that that's the function because we already know how to write a function, so we know that this is true. This is where you can now plug in a number. So let's plug in a 1, see what we're supposed to get, and then see which of those answer choices matches. So to the power of 1, anything to the power of 1, does it change the value of that number?
No.
No, so we're just going to multiply calculators out. What is 29,000 times 1.062?
30,798.
30,798. So which of those graphs matches correctly?
A.
A. Exactly. A matches correctly because B is much, much larger. We were looking for somewhere around 31,000, and that's what we got. So see how this works with when you have a graph. First of all, eliminate any answer choices that are just dead wrong. So C and D were dead wrong because they started at the wrong number. And then if you have to choose between two of them, try to match them up. Try to see which one gives you the right output value for 1 year or for 2 years. You can plug in, we could have done the same thing with 2. Well, not really, because answer choice B doesn't even show us what the value is after 2 years. It doesn't show it to us. But you could have done it with answer choice A. You could check 2, you could check 3, and then see which one matches correctly. Questions on this one? We got 5 minutes left. Yes, I will be posting the video today. So you can go back and rewatch. I know I'm going fast, so you can rewatch it later on a slower speed. Okay, real quick. Julian graphs the function f of x equals 2x to the power of 5. Then he moves the graph down 8 units to create g of x. What is the y-intercept of f of x? What is the y-intercept of g of x? What would be the y-intercept for f of x?
6.
Good, 6. 0,6. How'd you do that, Lauren?
The parent function, the original y-intercept is 1, and then you add 5.
Perfect. So remember, the number at the end just tells you how much, so 5 up from 1. The original function, the parent function, starts at 1, so that's how much you're going to add. So we end up with 6. Another way to do that real quick would be to plug in what number? What can I plug in to find my y-intercept? On any graph in the world, the y-intercept is wherever x equals
0.
0. So we plug in 0 and then solve. 2 to the power of 0 is 1. 1 plus 5 gives me 6. So you could have done it both of those ways. Either way, you get 6. What about for g of x? Moves down 8 units.
-2.
-2, good. 0, comma, -2. And that's because from f of x, which is at 6, now we go down 8 units. So 6 minus 8 is -2. Okay, then which of the following correctly states the relationship between f of x and g of x? Take a look. If you know the answer, you can shout it out.
B.
Good, B. G of x is f of x minus 8, down 8 units. What would A be?
It will be up 8 units.
That would be up 8 units. What would C be?
C will go to the left.
Good. That would be left 8 units, and then D
Right.
to the right. Okay, questions on this one? Okay, real quick, I know we didn't get to these last 3, but that's okay. That's okay. It is what it is. Topic 7, assessment. So quickly, just to go over everything that's on the test. Rules of exponents and radicals, adding and multiplying rational and irrational numbers, and then exponential functions. So pretty much everything we worked on today. I tried to get as much of the similar types of questions as the ones that are going to be on your test. Part 1 is tomorrow. That's no calculator. Part 2 is on Wednesday, calculator allowed. And remember, there is a calculator on the screen, so you don't need to have a physical calculator with you. Thursday and Friday will be makeup days. Also, each section of the test, I believe, has 12 to 15 questions. I don't remember how many specifically, but I'll tell you that tomorrow. 12 to 15 questions each. Questions on anything for today? I know we only got 1 second left. All right, guys, study tonight.
Today or tomorrow?
Say that again?
Will this be uploaded today or tomorrow?
Today. I'm going to upload it right after class, right after, like literally in 10 minutes. You should see it up there.
Okay, thank you. Have a nice day. See you
Have a
tomorrow.
nice day. See you tomorrow. Good luck. Study up tonight, everyone.